Hello everyone. In our today's problem, we have to find binary prefix divisible by 5. So you'll be given a binary array nums, which will be zero indexed, and all you have to find is the number is divisible by 5. And how can you count this one? It's like you'll count from nums 0th index to the ith index. So for example, if this is a test case, so on the 0th index, the number will be 0. Okay, and the second number will be 0, 1 as the past number is 0. Then the third number will be like all numbers from the from the beginning, so 0, 1, 1. So for example, the array is like this. So here the number will be 0, then here will be 0, 1, here again 0, 1, 0, 0, 1, 0, 1, like this. It will be continue. So now the problem statement says like is this number is divisible by 5. Okay, 5. Is this one divisible by 5? If it is 5, put true, otherwise false, false. So you have to create a Boolean array and you have to keep uh, pushing the response as a true or false. Okay, so if I take this one again, so our first number is 0. And if we divide 0 by 5, answer will be 0. So the response will be true. So first one will be true. Okay. Second one is 0, 1. Means from the binary, if we convert in the decimal, it will be 1. If you divide 1 by 5, the rem remainder will be 1. Okay, 1. So it will be false. Again, this one will be 0, 1, 1. So what is the decimal number of 1, 1? 1, 0 is 2, 1, 1 is 3, right? 3. So if you divide 3 by 5, it will be 3. Okay, means the remaining will be 3, right? So if I put mod here, so mod will be 3. So it will be again false. False. Have you got it, right? So that's what you have to return. Now, how can you convert the binary to decimal? So there are multiple ways. If I tell you like 0, 1, 0, 0, 1. Okay, what is this number? How can you tell it? So the one way to tell it to know the position. Okay, so this is one position. This is 2. This is 2 into 2, which will be 4. This will be 4 into 2, which will be 8. This will be 8 into 2, which will be 16. Okay, so numbers here is 1. So it will be 8 plus then this one. So 1, which will be 9. Have you got it right? So now if I copy one thing, so it will be more easier for you. Let me copy it for you guys. Before that, what I wanna mention that here, if you have a look, for example, if this is a number, okay, 1. Now, if you add one more number here, means this this number is gonna increase by 2 plus one more number, right? So this one 1, 0. So first, if I copy this one, it will be more easier for you. So if you look at this, chart. Okay. So here, if you have a look on one, okay, on one, if you add one more zero after this one, what it become? 2. So 1 into 2 is 2, right? So this one is 2. If we add one more zero here, what it become? 1 0 0. If you find 1 0 0, it is 4, right? So what it does it mean? Like previously what we mentioned, like the is decimal is like this: 1, 2, 4, 8, 16, 32. So means if we keep adding one more value, it's gonna increase by twice plus the last number. Okay. Now, for example, this is 2. Okay, 2 means 1 0. Now, if you put 1 here, what does it mean? Means you're gonna do 2 into 2 plus the last number, which will be 1. So it will be 4 plus 1, which will be 5. If you have a look, 101 is 5, right? Now, this is 101. Okay, if you put 101 and then again put 0 here, what does it mean? Means 5, and if you put another one more position here, means into 2 plus the value you are putting, 0 or 1. So it is 0. So 5 into 2, which is 10, and plus 0, which will be again 10. So if we go to 10, we can see 1010, right? That's it. For example, this one, 6. Okay, 6 is how? 110. Now, if you put 1 here, okay, so this one is 6. Means 6 into, we are putting one more value, so into 2. Plus, what value we are putting? 0 or 1? It is 1, so 1. Okay, 6 into 2, which will be 12, plus 1, which will be 13. If we have a look at the 13, it is 1101. 1101. So that's how. So 1101, if you put one more 1 here, so what is this one? 13 into 2. Then what value we are putting? 1. So 26 plus 1, which will be 27. So, so that's how you can calculate. Now, if you get 27, 27 here, so just mod it by 5. If you get 0, return true, push true, otherwise push false. Okay, so what we can do, we'll be writing int car is equal to 0, and vector bool, I can say response, and I can keep pushing, or I know the fixed size of the response, so I'll be saying that size. Okay, to avoid creating any extra memories. Return response. Okay, let's say for anti-I equal to 0, I less than nums.size, I plus plus. Okay, so I'll be saying I'll be keep like I'll be increasing the value of I will keep updating the value of car. So car will be car into 2 to 2 plus nums of I, the value we are getting. Okay, then I can say response dot push. Oh no, here I will be saying response of I is equal to car mod 5 is equal to 0. That's it. Now if we push this one, you will get an error for this one. Like if I run this code, you'll get a runtime error because of signed integer overflow. In that case, what you can do, you can keep dividing the value here. So you can keep getting the mod here. If you get mod here, the result will be same and it will pass through all of the test case. Okay. And instead of into 2, what you can do, like you can use this operator. Like, it is right shift, no, left shift 2, left shift 1. Yeah. So for example, 2 will go, so for example, it is 2, so 1, 0. So if you use this one, left shift 1, so it will be 1. It will go left, left, one more go, and it will add 0 here, right? So this is the bit manipulation thing. So you can say, no, I think this is, yeah. And if I submit my code, it should get accepted. It is, guys. Thank you so much.